Hello everyone, and welcome to this week's Secrets of Flow. This is your weekly time and place for insights and practical advice on improving the world of work and outcomes for businesses and customers who rely on modern, largely invisible, intellectual, creative type of work. I intend to keep these insights coming from different angles. And for today's angle, I chose the topic, you saw the title, the elusive 20% time. I chose a story that broke out some time ago and sparked quite a debate. We were told that engineers at Google spend 20% of their time working on projects of their own choice. And engineers at other companies tried introducing the same practice in their companies and mostly ran into resistance and skepticism of managers, or if they got past that, they got mixed results. I chose that story not just because it's interesting, but because it actually contains lessons for all of us many years later. In every debate, there are of course some nuggets of wisdom, and we will absolutely get to those today. And there's sometimes lots of things said back and forth that kind of miss the point. And there was of course a lot of that as people debated the 20% time story and what to do about it. However, those nuggets of wisdom that were present in the debate about 20% time at the time, they're still relevant, and they will unlock some of the secrets of flow for us. Secrets of how our work really works and how it flows through the company. So we'll understand something about the nature of it, something that's pretty simple and important. And that will lead us to some practical advice for three kinds of people. First, if you manage a program in your company, maybe product development work, maybe some professional service or project work, and you have a mix of, let's say, dedicated teams and some shared services and specialists, perhaps an interesting situation. How to keep this flow balanced and smooth and avoid some of the frustrating delays that may happen. So that's number one. Number two, what if you run a business, an enterprise that uses a lot of outside vendors and outsourcing? How to keep the relationship with your vendor healthy. And number three, it's about overburdening that is now pervasive in a lot of intellectual professions. Software developers 15, 20 years ago, that was just a canary in the coal mine. A lot of professionals face a lot of demand on their services, huge workloads, and stress and potentially burnout. What to do about it and from what angle to approach it. So let's begin. Let's go back to that story. So 20% time. Let's say you're working in a software company and you heard this story. Well, you probably know some friends who work at Google, and you've heard maybe they have a somewhat higher salary, and they have a nice office, and they live in California where the weather is nice, and they have nice offices and good food in the office, or even massages. And now this. It's like adding an insult to the injury. 20% of time to work on whatever you please. Well, it's usually kind of connected to the company business anyway. Maybe you are refactoring some old code, maybe you're improving design a bit, maybe experimenting with a few things, maybe you're learning a new tool, or maybe you're creating a new tool that can automate some of the tasks of your team. So you're still probably doing something useful, something that's aligned with what your company does anyway, but you do it completely autonomously and without any direction in a totally self-organized manner. And so you decide to go up to your manager and propose that, we do something similar in our company. Well, let's put ourselves into the position of this manager. You hear this proposal, you're obviously surprised by it, and the first reaction, the first natural reaction in this case is, of course, some skepticism and some initial resistance. I don't really understand it. I don't like it. Why? Why would we do this? If this idea is supposed to work, can't we just do it with 20% fewer people and save money? And as a manager, you're responsible for this budget. Or while we are at it, why can't we just find a foreign country with cheap labor and maybe save 80% and not 20%? Why stop at 20%? And now some of the arguments for and against are thrown around. One of them is innovation. Actually, some of Google's innovative products resulted out of efforts that initially started as 20% time. So maybe it's innovation. Maybe it's creativity. Or maybe it's some measure of autonomy and respect and appreciation for the staff that perhaps, it doesn't always have to be money. Maybe the company can show its staff some appreciation in this kind of way. And so all these kind of cultural arguments don't necessarily convince the managers. And so, for the most part, they resist. Or if they decide to go with it, the typical result was, okay, well, once in a while we'll have a hackathon. And if it all goes well, then maybe, it will even happen during a weekday and not on the weekend. And this kind of debate kind of missed a really important point, and now I'm going to show you what this is really about. It's not about culture, and it is not about innovation or creativity. It's about this. I'm going to show you this chart. It's about a very simple kind of law of how the work works and how it flows. It's a relationship between utilization and responsiveness. A very high utilization means a system becomes unresponsive and slow, and that has some consequences. Now, what do I mean by utilization and responsiveness? So let's consider something simple. In the old days, when personal computers had only one processing unit and operating systems weren't as reliable as they are in today's laptops and smartphones that actually use multi-core processors, you could easily overload your computer's CPU by giving it some intensive task that occupied it, let's say, 100%. 100% utilization. Now, try to do some interactive task on your computer at this time. You start clicking the mouse and you wait for seconds or sometimes even minutes for, let's say, your word processor to respond. Because it just cannot get enough CPU cycles to process your input, because it's busy with that, it's almost 100% utilized with that intense computational task. Now, modern computers are largely immune to this problem. I very rarely see this sort of unresponsive behavior from my computing devices. And this is largely because actually the modern devices and systems are designed to keep their utilization at pretty low levels. We encounter utilization and responsiveness trade-off in our daily lives quite often. So let's go to, let's say, Starbucks in the morning to get coffee during the busiest hour. Well, let's say baristas can serve how many coffees per minute? Now, let's say 5. But what if customers arrive at a rate of 6 per minute, or 8 per minute, or 10 per minute? What happens? They queue up. There's a line. And at some point, the line is too long, and you decide, let's go to a different coffee shop. Well, and eventually rush hour passes, and now customers arrive, let's say, at the rate of 2 or 3 per minute, or even less, while baristas can still make 5 coffees per minute. So most of the time, they actually have some idle time. And you see sometimes similar situations, let's say, at the airport, when sometimes lines behind the rope grow quite long, and that's because passengers arrive at a rate faster than, let's say, check-in agents can serve them. However, the business class high status line, well, there's actually no line. There's no queue there. There's a couple of agents, and usually at least one of them is just waiting for the next customer to approach. Right? So you see two different systems side by side. One is designed to keep agents busy and customers waiting, and the other one is designed to actually make sure customers never wait, or wait as least as possible. And so there is a relationship between utilization and queuing. And now let's get back into some kind of creative knowledge work, doing something with technology or whatever you do in your professional field. We can model your work, or let's say your team's work, with kind of a very simple model. Let's just put it in a black box and call it a processor. So this is you or your team. You basically turn some incoming requests, for example, for new product features or whatever work item might be that you and your team deliver, and you turn them into completed work items. If your team's throughput, that is the number of completed items, let's say per day, per week, or per time, whatever unit of time is meaningful to you, exceeds the rate at which these work items arrive, then you're going to have some idle time, just like those check-in agents at the airport in the business class line. However, if the demand arrives faster, then it's going to queue up. It's going to create a backlog in front of you. And there is a big difference between intellectual work and, let's say, some of the, let's say, tangible work, such as at the airport or in the coffee shop. And that's because the demand really doesn't subside. The rush hour at the coffee shop will pass, the day will end, people no longer need coffee after a certain hour. Airport eventually empties out of all passengers for the night, but knowledge work doesn't stop. If you are in some kind of product business, professional services business, the new requests from the customers, the new product ideas, they just never stop coming. And the backlog keeps growing, and this is not a sustainable situation. So there is some well-known math around this, because clearly scientists studied this type of systems in the 20th century. And we can basically measure what the arrival rate is, what the departure rate is, and the ratio of the two is utilization ratio. And we can ask ourselves, okay, well, what kind of queue size can we expect as a consequence of, let's say, if the demand is this and the departure rate is that. So this is basically a solvable math problem. It's been solved by 20th century mathematicians, and basically the solution is the chart that I just showed you. You can look up the relevant formulas yourself. I don't want to complicate this show with let's say mathematical formulas. They're beside the point. You can look them up. And if we were to plot the chart of that formula, the utilization ratio on the horizontal axis and Q size on the vertical axis, then basically this is what the chart looks like. It's like a hockey stick shape, and it has an inflection point, and it appears that things begin to get worse around past the 80 or maybe 90% mark. Now, if you wonder what the units are on the vertical scale, that's the expected queuing time relative to the processing time. So if it actually takes 1 unit of time, let's say 1 day to process the request, then on the vertical axis is the number of days you can expect an incoming request to wait in the queue before it is processed, which takes about 1 day. So as we can see, if let's say the queue size is 50, that means some work item will spend, let's say, 50 days in the queuing state for 1 day of active work. So we get a roughly 2% flow efficiency, which is pretty bad. However, if we can cut, let's say, the queue size to about 10, then we're looking at perhaps 10% flow efficiency. So this is a very simple and yet powerful message that actually what's really important, the important thing about 20% time or 10% time or whatever percent time it is, it basically avoids a super high queue states which cause severe overburdening and severe unresponsiveness from whatever, let's say, software team or an expert group to which we send demand for some professional service, right? If they operate at a very high utilization ratio, that means we can expect very long response time for that group. And that could be bad for business, because if our products, if our services that we ship to our customers, services we deliver to our customers, depend on contributions of various specialists. That means every time we need a contribution from some specialist, the work will have to queue at their desk, basically, right? And so all these queues will add up to quite a long delay. As a result, we're shipping our product late, we're delivering our service late, and that certainly has consequences on customer satisfaction. It has consequences on, let's say, market share that our business can capture. It has an economic cost, which is known as the cost of delay. So we need to avoid such long delays, or perhaps the worst of it, by making sure that we keep our utilization at least below 100%, maybe preferably even below 90%. And that was really the point. If you can run your company, run your business, manage interactions between various teams in your company in such a way that you avoid super high utilization ratios, then the work will flow more smoothly in your company on its way to its happy customers. And several practical consequences and conclusions follow immediately. This wasn't about innovation, right? If your company cannot innovate during its core hours, 9 to 5, Monday to Friday, or for donkey work only, that's a problem. You need to find a way to innovate during regular hours. This isn't about creativity. We need to be creative during our regular hours on a typical, Tuesday afternoon, and not just at a quarterly hackathon taking place on the 5th Saturday of the second month of every quarter. And this isn't only about the workplace culture and respect shown to employees and their autonomy. There's actually real money at stake. Delays that accumulate maybe a few days at a time on the contribution of every specialist that has something to do with the product you eventually deliver to customers turn into delays of months and sometimes years when you ship the final product. It has very real economic costs. So businesses that count their money, which is, well, pretty much every business should, delays that occur due to queuing of work before people who do the work, that's money, right? This isn't just about the respect given to those workers. And some of the responses to the 20% time proposals miss the point in even the worst ways. So some people asked, okay, well, we're going to need to have a different code in our time tracking system for this type of work. Right? This clearly misses the point. And another response was, okay, well, let's set up the proposal and approval system where you can submit a project eligible for 20% time, well, except we have to decide if it's eligible or not, and we'll figure out some kind of appraisal system, and some projects will be approved, some will not, in which case you can submit a different proposal and whatnot, and we'll have a committee approving that kind of work. And of course, that just means even more overhead, right? And again, misses the point, because the point is actually not to create more busy work, it's rather get some relief from it. So we need to reduce utilization, and this is when somebody came up to me when I first wrote and spoke about this some number of years ago and said, oh, look, Alexei, if we, let's say, allocate 20% to one type of work, 80% to, let's say, core work, then isn't 80 the new 100? Didn't we just cut our capacity by 20%? Which actually means we just increased our utilization by 25%. Didn't we make the situation worse? Didn't we just dig ourselves a deeper hole? Didn't we end up in a more, didn't we just get stuck in an even worse utilization trap? And I said, you're absolutely right, 80 is the 100. Because this isn't about allocating capacity, it's about escaping the utilization trap. So the utilization ratio is something you cannot really choose. It's a function of two things: how much demand you get and your production rate, your throughput. Right? So number of items arriving per unit of time, number of items completed per unit of time. And you need to find balance of the two. So the demand in balance with capability, preferably slightly less demand than there is capability to deliver. Right? If they're perfectly balanced, it's 100% utilization, it's still bad. So you can work on both sides. Yes, there could be some investments in productivity, but you can also do a lot on the demand side. And here are some of the practical considerations. A lot of work is accompanied with rework, right? So we do some work, but it has some defects in it, and those defects come back to us. Customers are unhappy, they report those defects, and we have to fix them. And we usually have to fix them urgently. And that preempts new original work. So what's the balance of new and original work, or let's say value-adding work, versus defect fixing? Are we spending, let's say, 10% of our workforce's time fixing defects? Well, if we could avoid that, that's your 10% right there. And utilization goes down from 100% to 90%, with significant reduction of queue sizes. So we can find such payoffs in, let's say, investing incrementally in better quality of our products, better quality of our original work. We can also sometimes find that some of the incoming work isn't what we actually want to do. For example, our help desk, our call center, our teams in charge of resolving all kinds of incidents and production issues and calls from dissatisfied customers. How many, let's say, support tickets do we handle per month, per year? Let's say one particular organization handles 30,000 such tickets per year, about 2,500 per month. Can they handle less? Can some of this go away due to more reliable, easier to use product? Yes, it can. And that can drastically reduce utilization and drastically, non-linearly, if you will, reduce the time it takes to resolve a problem. So so that right there, I gave you some ideas of how you can tweak your proportion of demand versus capability and bring them more in balance. This has a direct economic cost. And now I'd like to speak about specifically about situations that I often see in companies, and I just want to speak it in a slightly more visual way, so I'm just going to bring up some diagram to share. So let's say you have a program and it comprises 4 teams. I'm just keeping numbers low so that just the math is uncomplicated. You can have 20 teams or 200 teams if you like, but just keep it simple and diagram less busy. And let's say they do some work. There's some starting point. You promise something to the customer, and then eventually, here it is. Let's make sure I'm actually properly sharing this. Here it is. Yes. So let's say there are 4 teams and they do some kind of work, and eventually the work gets to the finish line, you ship it to the customer is happy, and let's say there is certain rate of production or throughput, how many work items, let's just call them epic features, that your teams complete. This is usually not the full picture. I intentionally hid some parts of it. What else is in this picture? Well, there's usually some kind of shared service. There's some expertise that is needed. It must be built into your product in order for it to have desirable qualities, and that expertise resides not within those 4 teams, but let's say within some specialized group, which is shared among these teams and potentially shared even with other programs as well. This is a very common situation. And sometimes such a shared service exists, let's say, as a step in the process. So let's say it occurs at a certain phase in the process after some work is partly done, and sometimes you actually discover it kind of as you do the work, and let's say one of the teams gets blocked because they need some help from, let's say, an external expert. And so they go there, they place their request, the expert does their work, and that work, let's say, comes back to the team, and the team resumes work. So sometimes shared service dependencies materialize in this kind of way. And let's say the work is going all right, and it's kind of balanced. Now, at this point, you realize that in order for this work to be kind of flowing smoothly and without some very long delays, the shared services must not be overburdened. They must not run at 100% utilization. So let's say each of these teams can produce, let's say, 10 work items per month. Let's say like epic features or whatever you call your work item type. So 10 per month from each, so 40 per month from all of them. And let's say half of those work items will run into dependency on a shared service, and the team will need an expert to do some expert level work to contribute to the delivered work item. So the shared service gets 20 requests per month. That's their demand level. Let's say they have capability, or their throughput is 25 items per month, right? So now they're running at 80% utilization, and at 80% utilization, you can expect pretty decent response time. You can expect that the teams, like when they ask, let's say, an expert residing within a shared service for help, they can get an answer relatively quickly. But let's change something in this picture. Let's say we want to deliver more, or we want to deliver faster. There's some business pressures on us to do this. And so what we're going to do, what we're going to do here is introduce a fifth team into this picture. So let's do that. So here's the fifth team. And now we have 5 teams. And what just happened? 5 teams start working at the expected rate of 50 work items per month. Half of the work items hit the shared service. And now the shared service demand goes from 20 items per month to 25, which perfectly matches their potential throughput. But that also means the shared service is now running at 80%, instead of 80% utilization, it's now running at 100% utilization. And what we can expect to happen now is that the delays that you incur due to shared service dependencies are getting non-linearly worse with just addition of one team. So this basically pushes the shared service from its slightly underutilized situation into the position of complete overburdening. And it becomes less and less responsive. So we need to avoid situations where our services suddenly go into this sort of overburdening mode. And I have actually seen this in some companies. There were, let's say, 2 programs, and the senior management decided to make one of them go faster, and they reallocated one of the teams from one program to another. And the result was the opposite. Actually, the program that had an additional team slowed down, and that's because a certain expert group implementing the shared service for that program, they basically got pushed over the edge from a healthy utilization ratio to nearly 100%. And what's interesting, in the program that lost one team, actually that program accelerated because queues vanished at the specialist group that was implementing a similar shared service within the program. So the results were the opposite of the intentions. So this diagram that I just showed you illustrates how it is important to understand where dependencies on shared services, dependencies on pretty much any specialist. If you don't like the word shared service, that's okay, let's call it something else. But you're going to need specialist contributions if your product is complicated enough. And modern technological society, most products are. So every time you have that kind of dependency, you can expect some queuing of work to happen, and the amount of queuing will depend on utilization. So if you can avoid high utilization, you can shorten the delays. So understanding where these dependencies occur, how much delay occurs there, understanding the level of demand on those specialists. That's very important, because actually raising that demand, let's say by 20%, as we saw with the addition of, let's say, the fifth team into the picture, you can actually very easily go from the low utilization, low queuing zone into high utilization and high queuing zone. And this is very important if you manage this kind of multi-team, in this kind of multi-team product or project or professional services environment. So that's one insight and practical advice I promised you at the beginning. I also want to talk about a different type of situation and advice. What if, instead of, let's say, these specialists and shared services, we rely on outsourcing vendors? And this is a very common situation. Now, the big difference in this, from the previous situation, is that the outside vendor is outside your organization, and you cannot really control them. And whereas inside the company, you can choose to allocate and reallocate teams and workers. You can try different designs of your organization. With the outsourcing vendor, you just basically send them some request for work, and they do the request, and they come back to you with the result. And there is this is somewhat a dangerous situation. So outside vendors can often save costs for your company, and this is an important benefit. But there is no free lunch. It can still be a profitable proposition, but we have to make sure that we manage some potential downsides of this vendor relationship. What can the downsides be? Well, let's say we chose a good vendor. They're actually good at what they do, and that could be a reason why you chose them. Why choose a bad vendor? So we want them to be successful and sustainable as a business, right? Why would we want them to fail? If they fail, they will stop providing the services that we're paying them, right? So that will make us less successful, right? So we want them to succeed as a business. Well, if they succeed as a business, they're going to land more clients. They're going to grow their portfolio of clients. And now, besides us, they have other clients. And what's their utilization ratio looking like now? Perhaps it will go up. And the scary part is that we don't really control it. So the new client can actually utilize a chunk of their capacity that used to be ours. And as a result, we can see deteriorating level of service. We can see longer response times from the vendor, longer times to complete the same quantity of work, because there are more delays in addition to the value-adding work, more queuing. And that's a potential downside of the relationship, and that could be on the flip side of their success as a business, which is, of course, kind of joined to our success as a business. And we need to watch out for it. And it's very important to establish feedback loops, both tactically, frequent check-ins, and stand-up, like short but regular stand-up meetings to make sure nothing slips through the cracks. That if something was supposed to start last week and it didn't start this week, we don't wait until Wednesday this week to find out. Right? So that's a short tactical feedback loop. But we also need to have a more operational and strategic feedback loop that where we actually look at the total capability to deliver of this vendor, such as the number of completed requests, the time it took to complete them, on the average, at the maximum, what was the worst delay, and monitoring that information. And if there are any trends that start to emerge that, let's say, this performance begins to deteriorate, the times are getting longer and longer, then we need to step in and take action and figure out and assert our rights and hold the vendor to the SLAs. And the most important is to keep this feedback loop pretty tight, so that at the any sign of trouble, we can act sooner before that trouble becomes bigger and bigger. So, and that was the second bit of advice for leaders of companies, enterprises with a lot of dependency on outside vendors. And last but not least, I'd like to say something just about a very broad class of people in all sorts of professions, intellectual professions. And as I said, software developers 20 years ago, that was just a canary in the coal mine, and now everyone is overburdened in pretty much every profession. It's not about you. There's really nothing wrong with you. If you're good at what you do, people will find a way to your expertise. They will send you more requests, and that can cause overburdening. Requests arrive at a rate faster than you can process them. This is a systemic problem. If you work in a company where you are this kind of rare expert with deep specialized knowledge, you may find yourself in this sort of situation of overburdening. You effectively have two jobs at the same time. One job is based on your core professional or technical skills, and that's hard enough, but you also effectively have a second job as a manager of a service, kind of a small business within a big business, where you have customers who send you all these requests, and you serve them, and you maintain some level of performance and quality. And it's important to realize this is not a complete solution. It's just a direction where to go and where to seek this solution. It is effectively a management type of problem. You have to approach it as a management type of problem, and you have to look for a systemic solution. This isn't just about your personal productivity, and this isn't just about the workplace culture and how much respect you get in it. This is also a systemic problem, how demand and capability balance is managed in your organization. And this is, so you basically have to look for answers to that somewhere in the management ranks of the organization. This is the direction where to go. Folks, it's 43 minutes so far. I'm glad I've got some buffer before my magical 55-minute mark. And I think as far as reflections on that 15-year-old story of 20% time and the important consequences of it, such as learning about the inescapable relationship between utilization and queue size, and queue size has a lot of damaging effects on customer satisfaction and business results and employee overburdening, and realizing how various proposals for 20% time miss the point, and we're not going to miss that point again. 3 practical advice for people who manage multi-team programs with interesting relationships between their teams and specialists, companies that use outside vendors, and just simply overburdened people in various intellectual professions. This should be good enough for today. I would just like to say just a few loosely related things as a conclusion of this talk. First of all, I'm thankful to everyone who watches episodes of Secrets of Flow every week. Perhaps, some people perhaps watch every single one. Thank you very much, especially. And people who tune in occasionally, thank you too. People who watch recordings, thank you very much too. Today's episode will be annotated and annotation posted on YouTube at around 3 p.m. Eastern Time this afternoon. I plan to launch a textual version of these episodes. Whatever I said in these 40 plus minutes can be presented somewhat differently. Reading text should feel different than, let's say, watching this screen. And that might be useful to some people. So I'm going to experiment with that. So expect some announcements, perhaps a community post on this YouTube channel linking to some text that I plan to publish. So expect to see this and more of this in the coming weeks. I also want to take some of the loyal fans of this Secrets of Flow sequence a little bit behind the scenes and tell you a bit of a story how some of this knowledge was discovered and how it emerged. Of course, the story begins around 2009 when the story broke out, and there was a lot of debate about it. But something else happened in 2009, and that was a publication of this very interesting book, Principles of Product Development Flow by Don Reinertsen. And if we look at chapter 3, page 65, it has that exact chart that I showed you. And it also has some formulas, and that chart is very easy to reproduce in, let's say, Excel, if you know the formula, and you can look it up. Actually, that particular formula that I used to produce that chart, it relies on a certain assumptions about the specific queuing system that we're modeling, and of course realistic queuing systems, they break those assumptions to some degree. For those types of cases, 20th century mathematicians did their work as well, so there's somewhat more complicated formulas to handle those cases. But if you apply those formulas and plot the chart, it looks pretty much the same. Right, and this is something that is not covered in Don Reinertsen's book, but it is actually covered in his training workshop if you happen to take one since he wrote the book. And so then something interesting happened. As the debate still raged about 20% time in the software development circles, someone posted the question on Stack Overflow. And it was just basically kind of, okay, well, a software engineering question. Can we, let's say, let's switch to this window. Here. Yeah, here's the question. So someone posted it and basically sought advice of software people from various companies. How can we implement the practice? And that's basically when I replied, and it was basically the answer that kind of blindsided everyone, because people were framing it as a cultural issue. So they were thinking this is just about workplace culture, it's about respect and autonomy. And well, the thing is, people who are into software engineering and people who read this kind of books, basically the intersection of these two sets of people is tiny. And out of those people, who is going to be on Stack Overflow at the time? Well, it turned out just me. So I wrote that answer, and it took a lot of people positively by surprise, because they realized this was about something completely different than what they thought previously. And now it made perfect sense. And they were also somewhat blindsided by it, because it came out of something they should have known, right? This is basic queuing theory, which someone supposedly studied as part of their coursework in computer architecture, as part of their computer science degree, perhaps, right? So this is something that was on the back of their mind all the time. Yet it was somehow completely forgotten in the first few years of the actual professional software career. And so then something unpleasant happened. This question was actually closed by Stack Overflow as off topic, right? So Stack Overflow clearly preferred questions that are just about code. And at that point, I had to realize that enough of this, writing some content that people appreciate and then posting it on some website that I don't control, and I just, people can just easily edit it, delete it if they like. So I basically got my own blog, my own domain name, and just started writing things there. And then something else happened. And in 2012, I went to a conference, Lean Software and Systems Conference, in Boston, 2012. And that's when I met Don Reinertsen. And so I just ran into him, and he turned his head towards me and said, "I read your article. It got my attention. I had a Google alert to find out what people are saying about my book." And then we chatted for a few minutes, and he gave me a lot of encouragement and just motivation to keep doing what I do, keep learning about the nature of work, keep uncovering secrets of flow, keep writing and speaking about it, and to keep sharing what I found. And so I'm still doing this. And that's a big thank you to Don. One of the lessons, kind of besides the ones that he could actually put in the text of his blog. All right, 53 minutes. And that little tour behind the scenes is probably the last part of this episode. That should do it for this week. And until next week's, and the next week's topic will be, how long will it take? No, how long will it really take? And that will happen on December 10th. Thank you very much for watching. Best wishes to you. Have a great rest of your day. And goodbye.